Hi, I'm Diana Martinez, and I'm director of the McAninch Arts Center at College of DuPage.
Hello there. My name is Dr. Beth Kirkpatrick, and I am a biology professor at the College of DuPage.
So marigolds have an interesting background. They get their name actually based on religion, Mary's gold in honor of the Virgin Mary. And the marigold goes all the way back to the Aztec times. And the Aztecs considered marigolds a sacred flower because they look like the sun. And they bred them to create bigger ones and more attractive blooms. And then later, the Mexican community started to use them on their altars for Day of the Dead because of their vibrant color and their very pungent smell. And they were thought to attract the souls back home to the altar with their scent and their vibrant color.
Every living thing must reproduce to maintain the species. Among the different ways to reproduce, sexual reproduction creates the largest amount of genetic variation and the overall best chance of survival for a species. Flowers are the organs of sexual reproduction in plants, and the flowers of many plant species produce scents. These scents are composed of low molecular weight compounds that evaporate easily into the air. The petals produce and release the scents. Some of these smell good to us and some don't. That depends on the intended pollinator. Flowers release scents into the air to attract pollinators, and they develop and open during the warmer seasons of the year, which coincides with pollinator development and activity. The scents encourage pollinators to visit one flower to collect pollen, which contains the male gamete, and take the pollen to another flower of the same type to fertilize the ovules that are in the ovary. These contain the female gamete. After fertilization occurs, a seed develops. A seed contains the embryo, which will develop into the next generation of the plant. The chemical compounds found in flower scents are a complex mixture of volatile organic chemicals, also called low molecular weight compounds. Here are some examples of chemicals produced. Okay, folks, take a deep breath. Here we go. Roses produce cis-rose oxide and beta-damascenone, a rose ketone, and also beta-ionone. Carnations produce eugenol, beta-caryophyllene, benzoic acid, and methyl salicylate. Violets produced ionones. Lilies produce E-beta-ocimene, myrcene, and lilanol. Lilacs produce E-beta-ocimene, lilac-aldehyde, and lilac alcohol. Chrysanthemums produce terpene compounds. There are a wide variety of chemicals that are produced by flowers to create their scents. Pollinators are attracted to different scents, and flowers produce the correct scent to attract a particular type of pollinator. The production of a scent varies at different times during the day. Bees, birds, and butterflies are active during the day, so flowers with those pollinators produce the scents during the day. Bats and moths are active at night, so flowers pollinated by those creatures release their scent at night. Many pollinators prefer sweet scents, so that is what many flowers release. Some pollinators require a food reward, like hummingbirds, bees, and ants, so plants produce sweet, sugary nectar to be sure they come to their flowers. Beetles prefer musty, spicy, or fruity odors. Some fly-pollinated flowers even produce a rotting meat smell. Blech. Once a flower has been pollinated, it will stop producing scent. The flower will begin to produce the gas ethylene, which will cause the flower to close and the flower parts other than the ovary to decay. So remember, the next time you smell the flowers, it's not just for you. It's a conversation between the plants and the animals that pollinate them. If you have any questions, if you want more information, please contact me at the College of DuPage in the Department of Biology. Thank you.